This will also debut on YouTube later today, just in case you guys are looking for it. Okay, so Spencer and Josh, you with me?
Yeah.
So 1-3 is intercept, symmetry, odd and even functions, and intersections. Okay, so this is kind of starting to talk about what functions look like. We're starting to notice symmetry and things that become really important when graphing them. Okay, so I assume that you know what an x and y intercept is.
What's that?
And maybe more specifically, how do you find the x-intercept? Did everybody just say set the y equal to 0? And then to find the y-intercept, you set the x equal to 0, right? That's not new information to you? All right, let's find the x and y intercepts to example number 1. Let's start with the x-intercept. How do I find the x-intercept?
Set the y equal to 0.
Very good. We set the y equal to 0. So we're going to go 0 squared minus 3 is equal to x. So would anyone else agree that we have an x-intercept at -3? So by the way, how would you list that as an ordered pair? -3, 0, right? So that's your x-intercept. Super. Okay, how do you find the y-intercept? Set the x equal to 0.
You're really confused by 0 squares. Okay. I got this.
0 times 0.
Yeah.
Okay, how do I solve this one? Did you have to prove that on a calculator?
He has to see it.
The calculator's right? Okay. Okay, now what? So what does this mean? What's the square root of 3? Good. Plus or minus square root of 3. And I would leave it as that. So we have 2 intercepts, so the ordered pairs would be 0 and a positive square root of 3, and 0 and a negative square root of 3. Piece of cake? I'll take that as a yes. What? Alright, do you understand symmetry over the y-axis? So if you take a piece of paper and you fold it on the y-axis, it's symmetrical over the y. Check. Do you understand symmetrical over the x-axis? That makes sense. Do you understand symmetrical over the origin? Can anybody describe to me symmetrical over the origin? How far? 180. It's kind of like a 180-degree rotation over the origin. Okay, so you should see whatever exists in this quadrant looks identical, like flipped this way, right? Okay, or you can think of it as whatever your coordinate is, you would have both negatives in the other quadrant. Okay. How can you test for symmetry? How do I know if something is symmetrical over the y-axis? Uh-oh. Algebraically. Just so you know, it's highlighted up on the screen right now. So if you substitute a number, so let's say you substitute 2, or you plug 2 into a function and you get 5. What would be the test? How would I know if it's symmetrical? So think about it. So if I plug in 2 and I get 5, how would I know that it's symmetrical over the y-axis? How would I get this? If I plug in -2, I get the same exact value, right? So I have to get the same value. Does that make sense? Okay, so to test symmetry over the x-axis, if I was going to use my same point of, what was this, 2, 5, how would I know if something existed down here? Okay, plugging the same y, okay? So substitute a number and its opposite for y, and you get the same number. Okay, and what about origin? So origin would be, what would my point be if this point was symmetrical over the origin? -2, -5, right? So that would exist at -2, -5, right? So if I plug in numbers, then I would get exact opposites. Okay. Dun, 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 dun. So check out that note. It says these informal tests are not foolproof. Think about whether other numbers would work the same. Okay. So you always have to think about things graphically as well. Okay, so let's figure out which type of symmetry we have. So for question number 2, I have 2x to the third minus x. So I could test all 3, but would it make sense for me to test all 3? Do you know what that looks like? What does this function look like? A John Travolta, right? So immediately, if I think of a John Travolta, this is obviously moved somewhere. Is a John Travolta going to be symmetrical over the y-axis? No, absolutely not. You got one arm up, you got one arm down. Okay, is it possibly going to be symmetrical over the x-axis? And therefore not a function? Absolutely not, you should be saying. Absolutely not. There's no way that that's going to be an even function, right? Or, excuse me, symmetrical over the x-axis. Okay, what about over the origin? How are we going to decide that? Okay, so it could be symmetrical over the origin. If it goes through the center like this, it could be symmetrical over the origin. So we're only going to test the origin symmetry test. Okay, so instead of doing all 3 of them. Okay. So how do I test this? Okay, so first I need a point to know about, right? So pick a number, let's plug it in. 2, I like 2. 2 is pretty easy. You never want to use 0, by the way, right? Because 0 isn't a good point. Okay, so if I plug in 2, I get, let's see, that would be 8 times 2, which is like 16, and then 16 minus 2 is 14. Okay, so I know that 214 is a point. So what I'm looking for is, what point do I need to be true for this to be symmetrical over the origin? I want a -2, -14, right? Okay, so let's try plugging in -2 and see if that results in a -14. Okay, so I got, let's see, -2 cubed is -8, and -8 times 2, -16, and -16, whoops, I almost screwed up. Plus 2, did you catch the plus 2? I almost screwed that up. So what's -16 plus 2? -14. So what did you conclude about this? Awesome. Okay, 3. What does this one look like? Which symmetry do you think we should test? What? Horizontal? Oh, so like over the y-axis? Oh, okay, I gotcha. I was just trying to figure out where that came from. Okay, so over the y-axis, everybody agree? Okay, so first thing we need is a point. Let's pick, let's just throw in 2. 2 is always a nice number. Ooh, yeah. So what happened here? What do I get? 0. So what do you think about this? Something symmetrical over the y-axis, and we plug 2 in. So how are we going to know if 0 is going to be a positive or a negative number is what I'm trying to say. You know what I mean? So 0, if we get an outcome of 0, that's not a good case for us to use. So we got to use something else. We don't want to get 0. So let's use 4. Okay, let's use 4. So 4 results in a 2. Okay, so let's think about y symmetry. What do I want to test? What is the point I want to exist? We want to have a -4 result in a +2, right? So if I plug in -4, will that result in the same value? Yes. Okay, so we can conclude that this is symmetrical over y-axis.
Wouldn't 0 be okay for this though? Because it's at the x-axis.
Yeah, it kind of is. Because I see what you're saying. Like if you think
It's not okay for the origin one because it's in the center. Like,
yeah.
Because you hit 0 at different points on the graph.
Yeah, I see what you're saying. Probably yes. I can't think of a counterexample, so I think it's okay. Yeah. Okay. What about number 4? What do you think that looks like for starters? Good. Since our y has the absolute value, it's your v that's tipped sideways. So which kind of symmetry should we test? The x-axis. Okay, so for x-axis symmetry, what do we want to do? So we're going to plug something in for what? Into our y, right? So should we use 2? Is 2 okay? This is going to be that same situation. Let's pretend we're going to use 4. Even though it's technically not too bad. Okay, so notice on this one, we're plugging it into the y first. Okay, so what would my x value be for this? 6. Okay, and then if I plug in -4, what will that result in? Okay, so that one is symmetrical over x. Okay, so one thing just make sure that you guys get is that you don't have to test all 3. It is possible for you to have more than one kind of symmetry though. Like a circle, right? A circle would have all 3. Okay, so just know what the function looks like and then use that information to help prove your symmetry. Okay, do you remember odd and even functions? Sort of. Okay, so hopefully you remember that even functions are symmetrical over the y-axis. Okay, and odd functions are symmetrical over the origin. If you can remember that, that's good. Okay, so even, and I always think of this as like an even function has an even exponent, right? So what kind of symmetry do parabolas have? Symmetrical over the y. Okay, an odd function would have an odd exponent, theoretically. So John Travolta would be symmetrical over the origin. Okay, so to decide if it's even, odd, or neither, we need to test what kind of symmetry we think it is. So for question number 5, what type of symmetry do you think we would have? What does this function look like? Okay, this is a John Travolta, so we know that it's not an even function for sure. Okay, is it an odd? How do I test for symmetry over the origin? Plug in a number. 2. So 2 to the third minus 2 would be 8 minus 2. Everybody agree that makes 6? Okay, so what I would be looking for is if I plug in -2, I should get negative 6, right? So if I plug in negative 2, I feel like we did this once before. Didn't we do this already? We get negative 8 plus 2, which makes negative 6. So what do you think? Is this symmetrical over the origin? Yes, we got a positive. Yeah, so they're both opposites. Yeah. So this is odd. And if you want, you can throw an exclamation mark at the end. Okay, what about 6? How can we prove that this one is which one? Even, right? So this would be even. Okay, so if I plug in 2 again, I would get, let's see, 2 squared minus 4, 0. I feel like they're just hammering this, but I guess we can still use it. So now if I plug in negative 2, what should I get? What answer am I looking for? If it's symmetrical over the same answer, right? So if I plug this in, I get 4 minus 4, which makes 0. And so I know that this is even. Yeah. Okay, what do you think about H? Which one would that be potentially? Or, yeah, H. You're thinking neither just because it had an odding, even odd, and now we're at the neither? Okay, so potentially over the y, right? Because it's an even function. It's a parabola. So let's throw in a 2 and prove that, in fact, Connor is right. 2 times 2, that is a lot of 2s. So 4 plus 4 is 8, 8 plus 2 is 10. And if I plug negative 2 in, do I get 10 again? Negative 2 squared plus 2 times negative 2 plus 2. That makes 4 minus 4, which is 0. And 0 plus 2 is 2. So, it is a neither. Okay. Doing good? How close are you? We're like almost done, guys. We only have one question.
So if it was like x squared plus 2x plus 2, then it would work for an even.
Wait, say that again.
If it was x squared plus 2x plus 2, would it work as an even then? Because, yeah.
2x to the 4th? I think so, yeah.
Correlation.
What?
Alright, last thing is how to find points of intersection without using a calculator. That's cheating.
But that's supposed to be fast. It's easy. Use calculators
This
all the
time. Without a calculator.
But calculators.
So, I will tell you, you will see this kind of equation, or this kind of example, over and over and over and over. So it's almost a guarantee that you will see something like this on the test.
Of course you don't.
Okay, so this whole idea of solving an equation for one variable and then substituting it in. Okay, or you can set them both equal to y and then set them equal to each other. Whichever you want to do. I think that is too. That's kind of the way my brain works. So how would you guys do example 8? What do you want to do? Do you want to set them equal to y and then set the two equations equal to each other and solve for x? Or do you want to do a direct substitution, solve for 1 and plug it in? Method A or method B?
Method B.
Oh, you guys all picked the different ones. Do you guys want me to do both scenarios?
Yeah.
Oh my gosh, okay, let's do both. Okay, so method 1. I'll do both for you, but I'm going to do it fast. Okay, so method 1 says solve the equation for one variable and then substitute. So when I look at both of these, I think the easiest variable to solve for is the x on the left-hand side. Right, because all I would have to do is simply add that y. So would you agree that that left-hand equation is 1 plus y? Okay, so then all I would have to do is do a substitution and take this 1 plus y and plug it into the x of the other equation. Okay, so the way that would look would be 1 plus y squared minus y equals 3. And now I can solve for the y. So, if I solve for y, I have a quantity that's been squared, which means I have to FOIL or expand that first, right? Okay, so you guys remember that if I have 1 plus y squared, that's 1 plus 2y plus y squared. Did I lose anybody there? Okay, and so now I'm solving a quadratic equation. I need it set equal to 0. So I'm going to pull everything to the left-hand side and simplify my like term. So I have x squared. How many y's do I have? 1y. What's my constant if I subtract 3? Minus 2. So now I can do the easy method of factoring. I need two numbers that multiply to -2 and add to +1. Two numbers that multiply to -2 and add to +1. So +2 and -1. Is everybody following this? Remembering how to factor? Okay, so I get two y solutions. What are my two solutions? -2 and +1. Now, am I finished at this point? No, because what did it ask for at the very beginning? We're looking for points of intersection. So points include an x and a y value. How am I going to find the corresponding x values for these? Plug it in. Which one do I plug it into? It doesn't matter. I can choose either equation, right? I'm going to use the first one because it looks easier to me. So I'm going to say, well, that's not cool. Don't do that again. So, oh, that's going to be annoying. Hold on. Sorry, I'm going to kill this for a second. OneNote's not playing nice. Oh, good, in it. There we go. Okay. So where were we? So 1, and can I go ahead and say +2 so minus the y? Follow that? So I would get x being -1. And then if I plug in 1, I would have x minus 1 equals 1. So the other x value is 2. So I have -2, -1, and 1, 2, are the two solution points. How do you guys feel about that? That was simple? Okay, do you want me to show you method 2? The other way? Oops, method 2. Okay, so method 2 asks you to solve both equations for one variable and then set them equal to each other. So my brain naturally works to solve for y because that's what we always do when we solve equations. So if I was going to solve the left-hand equation for y, what would that be equivalent to? What would y equal? First equation. Close. X minus 1? There we go. Just think about it, you'd add the y. Okay, what's the other equation going to be if I solve for y? X squared minus 3, there you go. Okay, so then all I have to do is set the two equations equal to each other. So I would have x minus 1 equaling x squared minus 3. So I'm solving a quadratic equation. What do I have to do? Move it to one side. So I'm going to subtract the x, add the 1. I would have x squared minus x. I'll agree that -3 plus 1 is -2. So therefore, I have easy method of factoring. Two numbers that multiply to -2 and add to -1 are -2 and +1. So my two x solutions are 2 and -1. So those are my x solutions. How do I come up with their corresponding y's? Plug them in. I like that left-hand equation best. So I do 2 minus 1 to get 1. So that one gives me 2, 1. And negative 1 minus 1 is negative 2. I was using the first one, the first equation. What's that? So we got the same solutions, yes? Oh, because I wrote the first one backwards. Oh my gosh, I wrote them backwards. Did you guys even notice that? Come on, those are extra credit points. Gotta catch my mistakes. Did you guys see that? My bad. So the x goes first. Negative 1, negative 2. And then 2, 2, 2. 2, 2? No, 2, 1. My bad. Sorry about that. That's my bad. We did it, guys. Question.
Why don't the x is equal? Like one and negative 2 and positive 2.
Why are they not the same? They are the same. Are you looking, so like, on this method I got x's of 2 and negative 1, right? And then for this one, my x's were 2 and negative 2. See that?
Oh,
these ones I solved for y. Which I kind of wish they would have got like more numbers than just 1s and 2s. So it was less confusing. Okay.